Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system. And first spotted this object back in July. It's a comet, now named 3I Atlas.
When 3I Atlas blazed past Mars, every instrument we had in orbit was locked on it. But just as the object came into range, one by one, everything went dark. And Mars went silent, all except one. A single rover stranger on the Martian surface survived. And the photo it sent back might be the first real proof we're not alone.
Scientist Avi Loeb believes the discovery of interstellar objects might be proof that we're not alone.
NASA won't confirm it, but behind closed doors, they're terrified. The perfect window. It was the kind of alignment that only comes once in a generation. 3I Atlas was about to pass near Mars, and every available eye humanity had in space was pointed directly at it.
3I Atlas, this is Mars. 3I Atlas is about to swing by, and a fleet of camera-ready rovers and orbiters are standing by to snap some pictures. So stay tuned, because the closest pass.
Since its discovery in early 2025, 3I Atlas had refused to behave like any typical comet. From the beginning, astronomers had flagged its strange plasma envelope, its sudden color changes, its heavy metal tail, and a speed that never quite matched expectations. But what made October stand out was the fact that, for the first and possibly only time, the object would come close enough to Mars to allow direct observation from relatively short range. Mars would be only 29 million kilometers away when the object reached its closest approach. In astronomical terms, that was almost uncomfortably close, and it placed Mars in a unique role as a forward observation post, perfectly positioned between 3I Atlas and the Sun, far enough from Earth to get a cleaner view and equipped with a fleet of orbiters ready to respond. Every major space agency knew this window was a gift. A narrow stretch of time, just between October 1st and 7th, when 3I Atlas would be near enough to capture real data. After that, it would disappear behind the Sun's glare, untraceable until late December, by which point it would be farther and likely too dim to study with any precision. Every major space agency mobilized. ESA's Mars Express redirected its particle sensors. The Trace Gas Orbiter was reprogrammed to scan for heavy elements in the object's trail. NASA's MAVEN probe recalibrated its plasma instruments just in case that strange electromagnetic sheath was more than a visual effect. But the most important system of all, the one everyone was counting on, was the Mars Reconnaissance Orbiter. Its camera had proven itself for years. With the ability to resolve features smaller than 30 centimeters from orbit, it was among the sharpest tools ever sent beyond Earth. The object would still appear small, but this was no longer about blurry trails or distant estimates. This was the chance to see what it actually looked like. Every system was primed, every frequency cleared. Mars was ready. But then something began to change. Not in the object, but in Mars itself. Silence from orbit. On Mars, where every spacecraft runs on the edge of survival, radiation exposure, signal timing, solar input, communication isn't just important, it's everything. Each probe, each orbiter, each lander is a lifeline. Without signal, Mars may as well not exist. In the early morning of October 5th, that lifeline snapped. It began with MAVEN, the Mars Atmosphere and Volatile Evolution Mission. Since 2014, it had been monitoring Mars' upper atmosphere, quietly recording solar activity and magnetospheric shifts. But as 3I Atlas moved into range, MAVEN's instruments started reporting values that made no physical sense. Particle counts surged in repeating waves. Each one hit thousands of times above baseline. It wasn't random. The bursts came in rhythm, steady, sharp, sustained, and they didn't match any known solar event. The probe's plasma detectors, hardened to survive coronal mass ejections, saturated completely. The software tried to recalibrate itself, failed, then locked out. Within minutes, its clean telemetry stream turned to fragments. Engineers watched years of reliable data dissolve into static, live on their screens. Then the trace gas orbiter faltered. A stable workhorse in orbit since 2016, it suddenly lost orientation. Its star trackers, used to lock onto fixed points in space, failed to find anchors. The orbiter drifted. A failsafe triggered. TGO shut down non-essentials and dropped into energy conservation mode. No instrument data, no communication. Nothing but a slowly spinning shell. This was no random glitch. Both failures followed the same pattern. Systems blinded or scrambled by something they couldn't explain. And above them, the sky around Mars had changed. Spectrometers, once tuned to detect faint traces of methane or carbon dioxide, began pulling in noise. Not interference, not bad readings, just blank white static. As if the entire upper atmosphere had been flooded with energy, masking the chemical fingerprint of the planet itself. And then came the Mars Reconnaissance Orbiter, launched in 2005. Its camera was legendary, detailed enough to spot a dinner plate from orbit. Scientists had hoped it would be the first to image the surface of 3I Atlas up close. But when the images started coming in, something was off. What should have been crisp visual data came back as warped and smeared. Frames tore into vertical strips. Horizontal bands of static stretched across the screen like a broken VHS tape. For a brief moment, it looked like someone had unplugged the feed mid-transmission. Onboard systems flagged voltage spikes. Guidance software attempted a reboot. The orbiter shut its camera. Emergency protocols kicked in, placing the whole system into standby. Just like that, Mars went dark. 3 orbiters, each isolated, hardened, and built for different missions, had all collapsed within the same window. 6 hours of total silence followed. A blackout not caused by impact, not by solar storms, but something else. Something tied to proximity. The only common factor was how close they were to 3I Atlas. But one system didn't fail. On the ground, far from the charged upper layers, the Perseverance rover stayed online. Buried deep inside Jezero crater, its systems flickered but held. Radiation sensors spiked. Its antenna stuttered, but it never fully shut down. Almost like it was beneath the storm, hidden under the surface chaos. And this time, Perseverance was running on autonomy. The command sequence loaded weeks earlier had been simple. Prep for low bandwidth, limited transmission windows. Continue scanning, stay on script. So it did. With no contact from orbit, with Mars above spinning in digital silence, Perseverance lifted its camera toward the sky. The image it captured would ignite one of the most divisive debates in modern science. The Perseverance image. The moment had not been expected to deliver much. NASA had planned the rover's sky-pointing maneuver weeks before the blackout, more as a redundancy than a priority. With the high-resolution orbiters above, Perseverance's contribution was seen as secondary. But now, with every eye in orbit disabled, this backup became the only witness. The first raw image was nothing more than digital blur. A distorted streak across a red-orange sky. It held shape. It had edges. But radiation had interfered with pixel sensitivity, and background temperatures were rising. Noise dominated the frame. Nothing seemed useful, until they looked again. Once the infrared overlay was applied, the blur began to shift. The Martian dust, Normally, a barrier acted like a natural filter, scattering low-energy light and letting higher-frequency detail rise. Slowly, within that haze, the object came into view. It was not what anyone expected. No jagged crust, no scattered debris. The skin appeared smooth, too smooth. The surface reflectivity matched polished metal, and it held its glow across multiple frames. What Perseverance had captured wasn't just another flyby silhouette. It was deliberate and unmistakably engineered. Across that surface, the camera revealed thin, unwavering lines. Some ran perfectly parallel for kilometers. Others bent into precise angles, sharp, clean, uniform. 19-degree crossings formed a geometric grid. One arc curled into repeating hexagonal shapes, like interlocked panels. None of it resembled fracturing. There were no natural pressure breaks, no heat-stress randomness, just symmetry. Natural bodies don't look like that, and scientists knew it. Within minutes of processing, the analysis team split. Some insisted it was a trick of lighting, maybe radiation-induced crystalline patterns. But others weren't convinced. The pattern was too consistent. The spacing, too perfect. In internal briefings, once banned words reappeared in reports. Constructed, artificial, designed. This wasn't just a rock. It was a surface. We also have the glow. Throughout its approach, 3I Atlas had carried a green coma, a halo of ionized metal that wrapped its body in light. But in Perseverance's final frames, that color changed. A yellow-red bloom began to form. Hotter, denser, narrower in the spectrum. The object wasn't cooling. It was activating. Almost in parallel, Earth-based telescopes started picking up a signal. Narrow band, rhythmic, repeating every second. It was too stable for interference. The data was sent to internal review, stripped of metadata, and locked behind restricted clearance tags used only for mission anomalies. The public got a filtered version. The real frames, the ones showing symmetry, glow, and rhythm, never left the servers. Because Perseverance captured a message, and no one knows if it was the last or the first. The question no one could answer. Inside NASA, the photo became the subject of relentless closed-door sessions. Analysts were ordered to examine it frame by frame. Every reflection, every shadow, every pixel checked and rechecked. When the composite enhancement revealed clean, symmetrical ridges cut into the surface of 3I Atlas, the room went still. Some engineers thought it could be compression artificing. Others said it looked like machining, the kind of detail you see in engineered surfaces. And that was the problem. The difference between the two was the difference between natural and made. The camera's metadata confirmed the exposure settings. The ridges weren't noise, they were real. They were there. That was the moment everything changed. NASA's comms team froze all external releases. The raw image was pulled from the shared database. Only a cropped and filtered version, stripped of infrared overlays, was uploaded to the public archive. The original stayed locked behind restricted credentials, tagged under Mission Anomaly. Officially, the reasoning was to prevent public misinterpretation. Unofficially, it was because no one had a better explanation. And that made it worse. The fear wasn't that the object might be artificial. It was the possibility that it had been sent, that it had passed through the solar system before, and was now back on a path, one that might include us. By late October, NASA's planetary defense teams had already revised internal models. A direct impact was still unlikely, but the probability of a significant electromagnetic event was upgraded to moderate risk. A single energy pulse, strong enough to shut down Mars orbiters, could cripple satellites around Earth. And that wasn't even the worst-case scenario. navigation systems, communications networks, flight paths, and global financial infrastructure, all of it depended on stable satellite function. If even a temporary blackout rippled across the grid, the cascade would be unstoppable. Behind closed doors, simulations were run. Most of them ended the same way, with silence and static. NASA released one final statement before locking down the file. No mention of the image, no comment on acceleration. The wording was calm, measured, and empty. But inside the agency, every new data packet from Perseverance was still being checked. Not just for technical readings, but for same residual trace. Something left behind. Whether that image captured proof of design or an illusion no longer mattered. What mattered was that it forced the most rational minds on Earth into silence. And no one can say what happens next. The image captured by the Mars rover Perseverance showed more than just structure. It revealed symmetry too perfect to be random, curves that repeated with precision, and angles that mirrored one another. No natural process could account for it. Not erosion, not crystallization, not the chaotic physics of interstellar ice. This was design embedded in motion, something that had purpose long before Mars even existed. Scientists called it coincidence at first, but as more data emerged, the more terrified they are to admit what it means. The silence from NASA isn't because they don't know what it is, it's because they do.